Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to discuss about what are the isomerism that we see in alkane. And in the previous lecture we have discussed about what are the isomers as well as isomerism and what are the types of isomerism that we are observing in the organic compounds, and we have discussed each one of it in a detail. So now let us talk about only the isomerism in alkane that we are observing, because this chapter is related to alkane. So let us talk about the isomerism in alkane that we observe. So let us talk about them. So before understanding that what is the isomerism in alkane that we observe, we know that isomerism is nothing but the molecules which will have the same molecular formula but different structural formula. And based on that we have also did its types. So now let us understand that what is the isomerism that we will observe in alkane. The isomerism in alkane is due to the difference in the structure of chain of carbon atoms. Basically, hence it is known as structural isomerism, because there is a difference in the skeleton arrangement of the carbon atoms, and that's the reason it is said to be structural isomerism. And the isomerism that has been shown by alkanes are basically known as chain isomers, because the only isomerism that they could show is basically chain isomerism when the carbon skeleton would be different compared to that of the other one, regarding that all the molecules that we are comparing, they should have the same molecular formula. So in that case we could say that they would have the different structural formula. That's the reason they will be isomers of each other, and moreover they would be structural isomers, and yes, they would be chain isomers of each other. So now let us discuss it with an example. Suppose if suppose if we have provided a molecular formula, that is C5H12. So this is the molecular formula that we have, that is C5H12, and based on this thing we have to detect that how many number of isomerism that this molecule having the molecular formula that is C5H12 will possess or will have. So for that, let us write the possible isomerism that could be shown by this molecular formula. So for that, we know, suppose if I consider the first one, where all the carbon atoms or all the skeleton of the carbon atoms are in a straight chain. So we could write it in this way. So this is the first possibility. The second possibility, if we could see a branched in the straight chain. So therefore, so this is a linear structure that we know, but let us assume that the another isomer would be a branched isomer. So therefore in this case I could write in this manner. And talking about the last one, or we could say that the another possibility, or what about the molecule having this molecular formula, that is C5H12, would be so this is the possibility, but let us fulfill the hydrogen molecules also. So what we have, so in this case all the molecules that we have drawn, we draw the skeleton, all the molecules possess 5 carbon atoms, but let us see that it should contain basically 12 hydrogen atoms. So for that we know that the carbon has a valency of 4, so in this case one valency has been fulfilled, so the rest is 3, so the 3 are remaining that would be fulfilled by hydrogen. So therefore in this case this would be CH3, this would be CH2, because 2 valency are been filled by forming a bond within 2 carbon atoms. So now here also it would be CH2, it would be CH2, and this would be CH3. So similarly here would be CH3, because these are the terminal carbon atoms, and terminal carbon atoms when it comes to alkane, they will have 3 hydrogen atoms. So therefore this is, and we could write it as here also as H, and here it is H. And if we come continuation. So if we compare these two things, we could see that the both will have the same molecular formula, that is C5H12. But what is the difference? The difference is in the skeleton, or we could say the difference is in the chain. So this is a straight chain that we have observed, but here is also a straight chain, but we could also see a branched a molecule or a group of atoms, that is CH3, that has been attached here. So talking about the last one that we have, here also we could write or fulfill the hydrogens. So therefore this would be CH3, 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 and ultimately here also CH3. So making the hydrogen molecules to be 12, but here is what we could see, that the skeleton, or we could see the chain or the structural the structural formula that we have wrote for each and every one would be different compared to each other. So therefore this three molecules are basically isomers of each other, having the molecular formula C5H12. So let us name it and let us see what is the difference that we observe in this case. So talking about the first one consists of basically 5 carbon atoms, and that too in a straight chain. So therefore this would be called as pentene. While the other one, this contains 4 carbon atoms in a straight chain, and the CH3, that is this molecule, methyl molecule, is been attached to the second carbon atom, so making this to be called as 2-methyl butane. And talking about the last one, that this is an molecule where we could see that the CH3 are been attached to the second carbon atom of the straight chain that we have. So therefore it could be called as, and both the groups are basically CH3. So therefore we could write it as 2,2, that is dimethyl, and the number of carbon in a straight chain is 3. So therefore we could write it as propane. So this is how we have arranged, or we have got to know that this is the isomerism that we could see in alkane. So this was a short example to discuss that this were the isomerism, basically the chain isomerism that we could see in when we are especially talking about the chain isomerism. So this is the chain isomerism that we could see in the alkane. And let us talk about another example while observing that what are the other possibility, or what are the other isomers that we could observe. So this is the one that we have observed. So let us consider that what are the different structural formula that we could see when we have an example of an octane. So when it comes to octane, we know that octane is the one which consists of basically 8 carbon atoms, and the total number of hydrogen in this case would be double than that of 8 plus 2. So therefore that would make the octane to acquire basically total amount of 18 atoms. So this is octane's molecular formula. But this is an octane, or we could say that the molecular formula having C8H18 could be octane. But yes, there are different isomerism also that we could observe. So the first thing that the first isomer that we could observe, or which is very easy to understand, that would be the main of which the isomers, the different isomers can be determined. So the first one would be the one which has the straight chain, that is when we are talking about the carbon skeleton. So therefore there would be basically 8 carbon atoms in a straight chain. So therefore this would become, we could write this in this manner. Second, the second isomers can be written in this manner, where the 7 chains would be in a straight chain, while the branching, or the 8th carbon, if we consider in that manner, so the 8th carbon would be on the second position. So these are basically the structural isomers of each other, and since there is no functional group that is been attached, so therefore this couldn't be come under the position isomerism. So now, but yes, we could see that there is a different arrangement. So therefore these are the chain isomers that we are talking about. So talking about the third one, suppose if this group that is been attached to the second carbon atom, if that would be attached to the third carbon atom, having the 7 carbon atoms to be in a straight chain. So therefore let us consider these are the 7 carbon atoms, and which the carbon is been attached to the that is the third carbon of when it comes to the straight chain. So, and another possibility that we have is, when the carbon, which are basically 7 carbons in a straight chain, that will acquire a carbon, when it comes to the 8th carbon, that would acquire the middle part, that is the 4th carbon atom. So again, in this case, as we could see, that there are basically 8 carbon atoms. So this is the fourth. So basically we have till yet calculated 4 isomerism. So let us see what are the other isomerism that we could calculate, or that we could estimate. Suppose if in this case, suppose if we have 6 carbon atoms that are been attached in a straight chain, so therefore we could write 1, 2, 3, 4, 5, 6. 6 carbon atoms are been attached to each other. So in this case, we could write that suppose the 7th carbon is attached to the 2nd carbon atom, and next to that, suppose if the 8th carbon is attached to this carbon atom. Even this is possible. And talking about the other one, that is again, suppose if 6 carbon atoms have been attached to each other, so therefore we could write in this manner. So 6 carbon atoms have been attached to each other, and in this case, what we could see that 1 carbon is attached to the 2nd carbon atom when we number it from left to right, and the 8th carbon atom, suppose it has been attached to this carbon atom. That is, when we count it from left to right, that is 1, 2, 3, 4th carbon atom. So this is a possibility, and there is another possibility to be an isomerism when it comes to an alkane having 8 carbon atoms. So the 7th one would be basically, we could write it in this manner, that is 6 carbon atoms in a straight chain that we have, and we attach the 2nd one that is in the same position that we have, and we'll attach the other carbon atom, that is the 8th carbon atom, on this carbon. So therefore, this is the 7th possibility that we have estimated till yet. So based on this thing, the another possibility that we could do when it comes to the 8th isomers, that is, we could write the 6 isomers, the 6 carbon atom as it is. So 1, 2, 3, 4, 5, 6. So these are the 6 isomers that we have, and suppose the 7th and the 8th isomer, they have been attached to the 3rd and the 4th carbon respectively, when we count from left to right or right to left. So this is what the same. So this is how we could see that the isomerism are being till yet been found to be 8. But yes, there are more possibilities. So let us calculate about that also, and let us see that how till extent the carbons having 8 carbon, a molecule having 8 carbon can possess how much isomerism or how much isomers. So talking about the next one that we have, we could observe that suppose if we have the chain that in this case, that is 6 chain in the straight chain. So therefore 1, 2, 3, 4, 5, 6. 6 carbons are being attached in a straight chain, and in this case, suppose the 2nd carbon consists of a carbon, as well as the 2nd carbon will also possess a carbon. So in this case, you could see that there are total making of 8 carbon atoms, and this is the another isomerism that we could observe. And talking about the another one, so this is what we have, but this carbon, if I attach over here, this would result in the 5th isomerism that we have got. So the reason is we cannot draw this isomerism again, or we cannot write the carbon atom here again so as to make an isomerism. So the thing is, let us predict the another one that we have, or that we could make, that is, suppose if we have make the 10th isomerism. So let us compare this thing by the first one, that is the 9th one in this case. And what we are going to do, we are going to make or put the carbon to be attached over here. So now this is the 10th isomerism that we have got. So in this case also, suppose if I attach this carbon to be attached over here, so therefore this would be similar to that of what we have drawn over here, that is the 8th carbon atom. So therefore we have to avoid, and yes, we have to predict what are the multiple possibilities that we could draw for the octane, or a molecule that consists of 8 carbon atoms, and that is an alkane. So in this case we have drawn up till this much, but we could draw more also. So let us try and attempt what else we could draw, or what else we could make a prediction that what would be the isomerism of a molecular mass C8H18. So let us consider for the 11th one. So suppose if we are talking about the 11th isomers, so therefore we could write it as when 5 carbon atoms are being attached to each other, and when it comes to the branching, suppose the second branch consists of 2 carbon atoms while the third consists of 1. So even this is a possibility, that is the 11th possibility. So now let us talk about the another one. So let us, for the another one, that is for 12th, we could write it as when 5 carbon atoms are being attached to each other in a straight chain, and the 2 carbon atoms are being attached over here, and that is, this is the 5th carbon atom, 6th and 7th, and talking about the last one that we have, suppose if that has been attached over here. So again, this is a possible thing that we have. And talking about the 13th one, so let us consider the 13 to have the carbon that we have been attached over here. Suppose if that carbon is attached over here, so therefore in that case what we could find it as, that is 1, 2, 3, 4, 5. Suppose 5 carbon atoms are attached to each other, and in this case we could see that if C is attached over here, and moreover we could see, and this is a neo carbon atom that we have got, because that is been attached to 4 carbon atoms. And the thing is, what we could do the next, we could make to be this carbon atom. If we have made the middle carbon atom to be a neo carbon atom, even that would be done. But the middle carbon atom, if suppose if we have made this to be neo, even that is possible. So let us make this to be, suppose, new. So this is new. As you could see, this is the 13th isomerism that we have drawn, and this is what the 11th isomers. Even here we could find a neo one, and from 9th actually we have got a neo. Here also we have got neos. So here it is what we have got the middle carbon atom to be the neo carbon atom. So this is what we have, and let us draw the next, that we are doing the more possibilities, so as we could find that how many isomerism that it could show. So let us consider for the 14th one. So suppose in case of 14, and if I have made carbon atoms to be in a straight chain, so 1, 2, 3, 4, 5. So this is the 5 carbon atoms that I have drawn in a straight chain. And in this case, suppose if I draw a neo carbon atom over here, okay, and the soon I have draw the one carbon atom over here, so therefore this both will be same to each other. They won't have a difference when it comes to, or when it comes to, suppose if I draw in this manner, suppose. So for this, if the carbon is been attached over here, and one carbon is attached over here, and the next carbon is attached over here, so therefore this would be similar to that of the 11th one that we had, as you could see. Because the neo, as we could see, when from left to right, we could see on the second carbon atom we could observe a neo and a carbon which is attached to the third carbon atom. So if we attach a neo over here, and we could attach a carbon atom over this third carbon atom when we name it from right to left, so the 14th and the 11th isomer, the both would be the same. So therefore what we are going to do, we are going to do a little a bit of different thing, so that as we could compare. So the thing is, we have basically 5 carbon atoms over here, and for that what we are going to do, we are going to insert, or we are going to add up 3 more carbon atoms. So for that case, what we are going to do, let us compare in this way. Suppose if we have made the attachment over here, the second, and this. So even this is possible that we have, that is, this is the 14th isomer that we have got, and this all consists of basically 8 carbon atoms. So this is the 15th one, and let us do for the 14th one, and let us do for the 15th one. So 15th one will also consist of the 5 carbon atoms, suppose in a straight chain. So therefore for which we have attached 5 carbon atoms in a straight chain. And in this case, suppose we have got a molecule like this one, or we have made an arrangement like this one, that is the 2 are being attached over here while 1 is being attached over here. So if this is done when 1 is being attached over here or at any place, so suppose if I attached over here 1 carbon, then this structure would be similar to that of what we have drawn in the first case, that in case of the 8th one. So in this case, suppose if we have added the carbon over here, so then this structure would have been similar to that of the 8th structure that we have drawn, that is this one, where in the 3rd and in the 4th carbon, when we number it from left to right, so it would have been containing the same carbon atoms. That is, in the 3rd also it would have consisted of 1 carbon atom, and in the 4th also it would have consisted of 1 carbon atom. So therefore this would have been turned into the 8th carbon atom. So as to avoid this kind of isomerism, so what we are going to do is we are going to basically not make those errors. So therefore we will not write the carbon over here, we'll write something which will make it very different. So therefore for that we have attached the carbon over here instead of writing the attachment over here. So in that case, what we are going to do, so this is the carbon that we have got, and moreover we could see that we could also attach the carbon atom that would make us to attached over here. So these are the 2 carbon atoms, but here we could see that 1 2 3 4 5 6 7 8 9 carbon atoms are being attached. So therefore we could eliminate this carbon atom. So this carbon atom would be eliminated, and this is the 15th isomer that we have got. So talking about the next one, that what we can do else. So for that we have talking about the 16th one, and let us consider for the 16th one. And for 16th one we could write the carbon atom, the skeleton of carbon atom in this way, that is we have 5 carbon atoms that are being attached directly, and for which 1 carbon is attached in the middle, and 2 carbon atoms that are being equivalently attached that are being attached in this carbon atom. So that will make this to be the 16th isomer. And talking about the 17th isomer that we could draw, so the 17th isomer would be very much easy to draw, and that would be nothing but this is the thing that we could draw, where 1 is being attached over here and the 2 carbon atoms are being attached over here. So let us see whether this is what we have got in other place or not. So the earlier one that we had, it had the structure that we have drawn in this manner, that is the 4 carbon atoms were being attached here, and in this case example also, if we could see that 2 carbon atoms are being attached in the middle carbon atom or in the 3rd carbon atom, and 1 is attached beside that or in the 2nd carbon atom. So here also if we could see that in this case where we have observed this one, so in this case also what we have observed that the 2 carbons are being attached but in the middle, but they are forming 1 neo and 1 would be the primary one, while in this case as we could see that it consists of 1 carbon over here and 2 carbon over here in this case. So therefore this is the 17th isomer that we have got. And let us talk about the 18th isomer. So the 18th isomer can be written as, where we could write the 6 carbon atoms as it is, and 1 to be attached in the middle, and that would be this one. So this is what we have made the isomer. So let us see whether this is being attached somewhere or not. So therefore if for that let us compare this thing. So this is the 18th isomer, this is the 17, 16, and this is the 15th isomer that we have got in this case. And talking about 15, 14, 13, 12, and this is, that is 11, 10, 9, 8. This is 7, 6, 5, 4, and ultimately we have got the isomers that has started from the first one. So this is what the isomers that we have talked about when it comes to the alkane. And this was an example where we have taken an example of an octane or a molecule which possesses 8 carbon atoms and 18 hydrogen atoms. So we could fulfill all the hydrogen atoms here also by knowing the valency of carbon, that is to be 4. So that also can be adjusted over here. So this was the example of the isomerism of alkane that I wanted to share with you. So thank you friends for watching this video. I hope you have liked this video and you have understood this video very clearly. So share this video with your friends, and just don't forget to subscribe Ekeeda channel. Thank you so much.